it's probably appropriate to talk a little bit about intelligence first, before talking about artificial intelligence. And there are many different ways to explain intelligence, many possible definitions, and I'm going to use this one. And according to this definition, intelligence is the ability to learn, understand, reason, and solve problems quickly and effectively. Now, what about artificial intelligence? You can look it up in a dictionary, and you will find something like this. I took it from a dictionary, and it's a branch of computer science that's dealing with the simulation of intelligent behavior, and it also refers to the capacity of a machine to imitate intelligent human behavior. So what you should notice from these definitions, it doesn't mean that the machine is actually intelligent, it just behaves intelligently. It kind of mimics a person that is intelligent. And this idea have intrigued mankind for a long time. And one of the early applications of artificial intelligence was a machine that could play chess. And it was called the Great Chess Automaton, or it had a nickname, the Turk, because it was a wooden Turk figure that was sitting behind a wooden desk, and there was a chessboard, and people could challenge this machine to play chess against them. And it beat, among others, Napoleon Bonaparte and Benjamin Franklin, and for 80-something years, it won almost all the games that it played. And remember that we are writing 1769, and no one really knew how. When the inventor, a Hungarian nobleman, Wolfgang von Kempelen, introduced this, he opened the doors, and there were a lot of machinery and different gears and wheels that were making a big noise, and people didn't know how it works. And it turns out that behind all that fancy machinery, there was a hidden box with a chess master hiding, and there was a magnet on the pieces, and he could see what pieces are being moved, and then he could make very clever moves. Right. So, well, you have to give a credit for creativity here. So then, some years later, someone actually built a machine that could play chess, or more like a chess endgame. And this game was about giving a checkmate with a white rook and king to a black rook, black king. Sorry, and you know that this is always possible, so you can always checkmate as white, and it actually did it in a mechanical way. It wasn't necessarily the most optimal way, the fastest way, or it was maybe it took more than 50 moves, and you know, after 50 moves, it's a draw. But nevertheless, it was a machine that could play this limited chess game. And then we entered into the age of computers, and in 1997 there was big news that a machine built by IBM called the Deep Blue beat the grandmaster of that time, Kasparov. And it was a big thing, and some people were very enthusiastic about it. Some people were maybe less. And this is one quote from one of the biggest thinkers of our time, Noam Chomsky, and he said about this: a computer programs beating a grandmaster at chess is about as interesting as bulldozers winning an Olympic weightlifting competition. So why did he say that? The reason is that it was mostly because of brute force computational power. That machine could analyze over 200 moves in a second and could foresee the game in 14 moves. So it's basically, I think that's an adequate comparison. This AI has been introduced as a scientific field in the 1950s. And it went through different periods of ups and downs, and you will see that there's always an up period when there are very high expectations, and there is a down period, winter period, when people realize that it's not really possible to deliver on those expectations. We are past 2 AI winters, and we are now in an up hype period. This is important to understand, because it means we have maybe very high expectations. And if you watch Game of Thrones, then you know that winter is coming. So there will be a down period, but nevertheless, big progress has been made. So in each of these iterations, we get further and further. But yeah, I mentioned that people tend to be maybe overly optimistic. So some of the and these predictions can go awfully wrong. So in 1956, it was predicted that machines will be capable within 20 years of doing any work a man can do. We are not really there yet. Or in 1970, from 3 to 8 years, we will have a machine with the general intelligence of an average human being. These were brilliant scientists, so it's not a criticism. It's just to point out that it's perhaps easy to get overly enthusiastic. All right. So what does artificial intelligence do? It's basically a thinking machine, and a very simplified view of it could be this. There are some signals that come from an environment, and there is that blue box, which is kind of the brain of the machine, and based on that input, it will give some response. We can distinguish between 2 kinds of artificial intelligence. One is called general or strong AI, which means it could perform any task that a human being can do. And according to certain definitions, strong AI even means that it's even capable of experiencing consciousness. The second one, applied or weak AI, is to accomplish some specific task. And in this talk, I will focus more on the second one, because this is something that's already surrounding us in many different forms. You can think of all of these tasks as the computer or machine is doing something that a person would do. So in case of a self-driving car, it's doing for you what a chauffeur would do. In case of a smart home, maybe you can think of a warden or janitor. This program is taking care of all the things around your house. Or you can think of a translator program, which does the same as a translator would do for you. All right, so we know that we can build such things. How does it work? The answer is machine learning, which is a subfield of computer science and a subfield of artificial intelligence. And it's concerned with giving computers the ability to learn from data without explicitly programming them to do certain tasks. We want them to learn how to do certain tasks. And here is a very high-level overview, and I will show more specific applications of this later. But the idea is that you have some data that you use to train this method, and it will learn a model that's in the blue box, and then you can use this model to make a prediction about some object. So let's look at one example, which is face recognition. I think many of you have seen this on your smartphones. If you have tagged some people on your phone in the photos, then if a new photo comes in, then it will automatically recognize who is on that photo. So how does it work in this example? The training data is pictures, faces, with the names of those people, and then the computer learns a model, and when it sees a new face, a new photo, then it will make a prediction who is on the photo. Okay, so it's important that it is making a prediction. It is not necessarily correct, but in most of the cases, it's correct. Another example is item recommendations. And you can think of items as movies that you can see on Netflix, or products that you can buy on Amazon or any e-commerce site. If you go to these sites, then very often you see some recommendations that are made for you. So how does it work? It makes use of your profile and the ratings you give to these different items. And sometimes you don't give an explicit rating. In case of movies, you can give a thumbs up or thumbs down, or you can give it some stars. In other cases, you just click on a product and you spend some time examining that product, and that's an implicit signal that this is something that might interest you. So this algorithm will learn that, and when a new item comes in, it can make a prediction how likely is that you will like that product or movie. All right, so now in the next slide, I'm going to take it one step further, and you will notice that I added that feature extractor box and those features in between the data and the model part. And what happens is that the computer doesn't understand these objects. It doesn't know what they mean, so we have to tell it how to interpret it. And traditionally, it's done by describing the important attributes or features of those things as an array of values. So in case of the movies, you can think of what is the genre of the movie, what year was it released, who was the director. These are all clues that we think as humans it would be useful for making predictions. And you see in blue are the target labels. So we know what we want to learn for each of them. It could be a name on the photo, or it could be a number from 1 to 5, how likely you are going to enjoy that movie. And then when a new object comes in, then we compute the same features and feed it to this model, and it will make a prediction. And this is very general, and this is applicable to many, many real-world tasks. And I just listed a few here. There are many more, but you can think of financial trading. A lot that goes on the stock market is performed by these intelligent agents. You can think of healthcare, for example, diagnosing cancer. These algorithms are much better at finding patterns than humans. You can think of security, detecting frauds or tracking people, marketing personalization, recognizing handwriting or speech, optimizing transportation, and so on. All right. So to sum up, what makes it work is really three things. One is that machine learning algorithm, which is just some mathematical method. I'm not going to say more about that. Number two is you need a lot of computational power to compute this. And the third one, and really the most important one, is data. Without data, you cannot make these things work. And in a way, what makes it work, it's us humans who generate a lot of data for making these machines learn. And in fact, you generate a lot of data without you being aware of it, that you are training some machine learning model. I don't know if you use these CAPTCHAs. Probably you have. And in one case, you have to type in some text, typically 2 words. And the truth is, in many cases, only one of them is compared against what you see there. The other one is used for training a character recognizer program. So they show to humans many of these examples where they are not quite sure how to transcribe it. And for example, those two words are shown to hundreds of people, and if most of those people agree, then it generates a training label. And the same goes with the picture of the cat. So for recognizing objects, the machine needs a lot of images that have cats on them, and by ticking the cat, you can help it learn how to recognize a cat. All right. One more thing that I should mention here, because you have probably heard about it in the news, is deep learning. There's a lot of hype around deep learning, and this is one particular machine learning method that is based on artificial neural networks, and this is something that is inspired by the architecture of the brain. Artificial neural networks are not really new. They have been around for several decades, but what has changed is that now we have the computational capacity to use them, and also we have enough training data. What is really important to mention here that it's modeled after the architecture of the brain. It's not doing the same things as the brain does. I'm a computer scientist, I'm not a neuroscientist, so I will just admit that I know very little about how the brain works. But here is an example of the difference. For a deep learning method to learn to tell apart a cat from a dog, you need to show it several thousands of images of cats and dogs. If you show a 3-year-old 2 images of cats and you show her 2 dogs on the street, she will be able to tell apart a dog from a cat in 99% of the cases, whether it's an animal walking on the street or it's an animal in a children's book. So the brain is amazing. What is interesting and important about deep learning is you remember this figure where we have this step of computing these features manually and constructing them. This is eliminated. So deep learning methods can learn from the raw data, and they can find out what is important about it without humans having to tell it and explicitly code those features. All right. Next, I will talk about search engines. And when I say search engines, just remember the first thing that comes to your mind, and then you can tell me if it was this. Okay, good. Indeed, in this part of the world, Google is the most popular search engine. It's important to note that search is not just Google. There are many other search engines, and you can find the search box in almost every application that you use or website. Why are we talking about search engines in this presentation, which is about artificial intelligence? Because search engines are one of the most sophisticated AI that exists today. If we want to use this analogy of a computer program mimicking the profession of some person, then the right analogy probably would be a librarian. So a search engine is trying to be someone that can give you access to all the world's knowledge. This is appropriate because this field actually has its origins in library science. So a search engine is a program that helps you find information. How does it work? You are a user. You put in the search box what you want to know about. Then the search engine will respond with a result page. And most of you think that that's where the story ends. No. When you make some interactions with that search engine, everything is being recorded and sent back to the search engine, and that's how it can learn. You know, I work on search technology, and one question I often get is, isn't search solved? Isn't Google doing everything already? You can look at this graph where you can think of all the possible search queries that people can ask. That's on the horizontal axis. And the value is how many times each query is asked. So on the left, you will see a lot of queries that are asked by many people. And often these are names of celebrities or products. And for many of these queries, if you type them in, you get a direct answer. The search engine is extremely clever. You ask it how to tie a tie, and then it won't just show you a list of documents, it will give you step-by-step instructions with an illustration. On the other hand, there are those search queries that are asked by much fewer people, and some might call it weird queries, and we all have our weird queries that we wouldn't like others to see. If you try one of these, or I'm sure you can think of your own searches, then you will see much worse results. Sometimes you get the impression that the search engine has no idea what I want to know. And that's because it doesn't have enough data. It's easy to answer it when many people ask that question and clicked on the document, then it can learn it easily. Where do we go from here? One might say that the holy grail of artificial intelligence is a machine that people can converse with. And if you think of Hollywood movies, then many of these portray artificial intelligence as some agent that can take different shapes and people can make a conversation with. You see that as time goes on, these more and more take a humanly shape. Maybe that's how we imagine it would look like. So the point here is that being able to make a conversation in natural language, that's a very important aspect of intelligence. So what is the present and what is coming now is what I call personal digital assistants. Many of you have probably tried Siri or the Google Assistant, and there are at least 3 important things that these assistants can do. One is that they can give you answers. When you go to a search engine, then in most cases you want to find an answer. You don't want necessarily a bunch of documents that you have to go through yourself, but you want something more direct. And you can already see this in Google, that for many of these requests that you have, you can get an exact answer. And this can come in different forms, weather forecast, a ranking of countries in terms of Olympic medals, or some fun fact you want to find out about a celebrity. Number 2 is making a conversation. So far it's very one-directional communication. You tell what you want to the search engine, and then it gives you back something, and maybe that's not what you wanted, but you don't really have a way to tell it. So this is an example of a conversation. When I could ask this agent what is the capital of Norway, then it would tell me that it's Oslo, and then I can ask about the population of it, and then in this case, by that I mean the population of Oslo, because that was the last thing we talked about. And in these conversations, it might happen that the agent doesn't understand what the user wants, and in this case, it should ask a clarification question. So, Number 3 is anticipating. So like a good assistant, tell me what I have to know without me explicitly asking for it. And these are actual examples from the Google Assistant, Google Now. It knows your travels if you are using your Gmail address. And if you arrive at the airport, it can pull up the boarding pass for you. And it can also pull up the weather that will be waiting for you on your destination. All right. there's a fourth thing that is very important. When people did studies about assistants and what matters to them, humor was on top of the list. So, you know, you want to have a conversation and you want to enjoy it in a way. So these are responses that Siri gives. I'm sure there are some humorists compiling these responses, so it's not as intelligent yet to come up with these on its own, but this is also very important. So how far are we from real intelligence? I've shown you a lot of examples where it works on specific applications. Let me give you a kind of thought experiment. Imagine that there are 3 kids playing with marbles, and you walk up to them and you ask them, what is 3 times 4? And first kid will say 7, which is not unreasonable because it has something to do with 3 and 4. It's just a right answer to a different question. Then the second one says it's 12. Okay, that's the correct answer. So follow-up question is why? He says, I don't know. And then the girl, of course, the girl is the smartest, always aligns the marbles in 3 rows and 4 columns, and says, okay, that's why it is 12. So you can think of it as kind of a continuum of understanding where we go from left to right, a wrong answer to a correct answer along with the understanding. And in my view, we are somewhere between 7 and 12. So in many cases, we can get the answer right, but we have no idea why, or the machine doesn't have any idea why. And in many cases, it will give an answer that is almost right, but not really for that question. So we can go back to this definition that to sum up where we are. And if we look at this definition of intelligence, we can say that certainly there is progress in learning, and these machines are able to solve certain problems, and those problems they can solve very quickly and effectively. In terms of, so one thing is that those problems are very specific problems. They can do one thing. Maybe it can play chess, but it would have no idea how to play a different board game, let alone come up with its own game. If you ask a 5-year-old, she or he can very easily invent a game for you, not so much computers. And the understanding and reasoning part is really limited, so they cannot really give an explanation. All right, what does the future look like? Many would say that the AI apocalypse is coming, and some evil super intelligence will take over the world. I love those movies too, but it will not happen. So you don't have to worry. It would mean that these methods have consciousness, will, and that would mean it can easily get very philosophical, but as a scientist, my opinion is that it's not going to happen. It doesn't mean that artificial intelligence is without dangers, and I just want to mention some things very quickly. So one danger could be that it needs enormous amounts of computing power. So these are really significant resources. It's not perfect, and it will make errors. So imagine a self-driving car hitting a person. Who is to blame? And very importantly, whatever you teach it, it will learn it. And I will end with this story. Microsoft developed a chatbot which was conversing with people on Twitter, and people could talk to it. And it took about 24 hours before it became completely racist, because people were tweeting Donald Trump remarks, and this is what it learned. So I will just give you some time to digest. Okay, so this is not artificial intelligence to blame. This is just how it works. You teach it something, and it will just replicate it. So thank you very much.